Okay, on this example, we're going to be using the Pythagorean theorem, and it says the path of a diver is given by this equation right here, y equals negative 4/9 x squared plus 24/9 x plus 10, where y is the height in feet, and x is the horizontal distance from the end of the diving board in feet. Assume that the end of the diving board is directly above the end of the pool. Part A says, according to this model, how high is the diving board? Well, we're assuming that the diving board is directly above the end of the pool, so the distance away from the pool would be 0. So we plug in 0 in for the horizontal distance, x, into this equation. If you plug 0 in here, you will get 0 times the negative 4/9, that's 0. 0 times 24/9 is 0, and 0 plus 0 plus 10 is 10. I actually have these coefficients in the quadratic sheet. I typed them in here for A, B, and C, and then you can just type in 0 for x, and you get 10. And then part B on this problem says, how far from the end of the diving board will the diver hit the water? Well, just remember, when the diver hits the water, his height, which is what y stands for, will be 0, since he's 0 feet above the water when he hits the water. So all we have to do is put 0 in for y. And I'll do that right here. If you put in 0 for y, you get two answers, and the only one that makes sense is this one right here. 8.612 feet is the answer to that problem. And then the third part of this says, how far from the end of the diving board will the diver hit the water? Well, on this problem here, we have a situation similar to this. Let's think of this as the horizontal distance. Maybe the pool goes out here farther, and here's the height of the diving board. So we know this is 10 feet from part A, and we know that the distance over here to where the diver hit the water is 8 point something feet, right here, 8.612 feet. And we're looking for this distance from the end of the diving board right here to where the diver hits the water. Now, I know that this isn't the path of the diver. The path of the diver probably went up and back down like that, but we're looking for that distance right there, and that distance would be a straight line. Well, the thing that ties this together, this would be a right triangle here, the thing that ties this together is the Pythagorean theorem, and it says if you take the two legs of a right triangle, you square them and add them together, you'll get this side squared. So it's a squared plus b squared equals c squared. So in other words, I got to take the 10 squared from the height plus the 8 point something squared, and that will equal this side squared. And then to get what the answer is, I'll need to take the square root. So I'll go ahead and do that. So off the side here, I'll do equals 10 squared plus this number right here, the 8.612, that gets squared, and that equals that distance from the diving board to the pool squared. So what I have to do is now take the square root of that, so I'll just do equals SQRT of, and no time sign there, just equals SQRT of that value right there, and I get 13.2, and that would be the distance right there. Again, it uses the Pythagorean theorem, a squared plus b squared equals c squared. You square this side, you square this side, you add them together, and you take the square root. Okay, moving on. On example 14, we have a rectangular field is twice as long as it is wide. Find the dimensions of the field if the area is 5,000 square yards. Okay, so let's say this is the width, so here's x, and how long is it? Well, it says it's twice as long as it is wide. Okay, so this length here would be 2 times the width. It's twice as long as it is wide. So this would be 2 times x. It might say something like 4 feet less than twice the width. Well, that would be 2x minus 4. Or if it says 9 feet less than 3 times the width, that would be 3x minus 9. So whatever is told to you, that's the other side. Now, how do you get the area? Length times width. So this is just going to be x times 2x, and that has to give you the area of this field, which we're told is 5,000. So area equals length times width, so 5,000 equals x times 2x. Now distribute that x across, and you get 5,000 equals 2x squared. We could solve this by hand by dividing through by 2. You get 2,500 equals x squared. Now take the square root of both sides, and you get x equals plus or minus 50. Either one will work, but the only one that makes sense is a length of 50. So actually this would be the width right here, because that's why sometimes it's worth it to label these things with W, and this one is L right here. And so if this is 50, then 2 times 50 would give me the length, and 2 times 50 is 100. And if you check it, 50 times 100 is 5,000, and that's what we're looking for. If you wanted to solve this bit right here on Excel, then it's a quadratic. The A is 2, and the Y value is 5,000. There is no B or C. So I'll do that. The A is 2. There is no B or C, and then 5,000 for the Y value, and you get the two answers that we said before, and the only one that makes sense is this 50. Okay, here on example 15 it says the ratio of the length to the height of the rectangle is 9 to 5. If the diagonal measures 12 inches, what is the area? Okay, so the way to do this is when they give you a ratio like this, that doesn't mean that this is 9 inches and this is 5 inches. It just means that this is 9 times some value, unknown value, and this is 5 times some unknown value. This is, like it could have a ratio of 9 to 5, like 9 and 5. It could be 18 to 10. It could be 12 to 7.5. Whatever gives you that same proportional amount, and I don't know what that is, so I have to get that x in there to do this problem. Now you use the Pythagorean theorem just like we did with that diver problem. So now we say this side squared, 9x, that quantity squared. A lot of people forget to put that in parentheses and they don't square the 9. So that 9x quantity squared plus this side, the 5x quantity squared, equals this side squared, because what we have here is a right triangle. And using the Pythagorean theorem again, this side squared plus this side squared has to equal the 12 squared. So now squaring this, 9x squared is 81x squared, and this quantity 5x, that quantity squared gives you 25x squared, and 12 squared is 144. Combine like terms here, you get 106x squared equals 144, and at this point you could do it on Excel, or you could do it by hand. Dividing through by 106, you get x squared equals that fraction right here, and if you do it on a calculator, don't round these values till the end, so just leave it 144 divided by 106, or do that and don't round it, just continue on with your calculations. And then we have to take the square root of both sides to get rid of the x squared, so it would be the square root of 144 divided by 106. And I'll do that on Excel too. You can do it right here on Excel where you have 106 x squared equals 144. The A would be 106. There is no B or C, and then we had right here, I think 144, and I get these two answers. Let me just check my coefficients and see if they're right. Yep, 106 and 144. So I get this answer here for x, which is a positive one, which is 1.166, and we don't have that right here, but it's 1.166, and now that is just your value for x. So if it wants to know the length, this bit here, okay, then we'll have to take 9 times that value of x. So let me do that off the side here, and I'll just do equals 9 times that value of x right here, and it's best to click on it. It's going to carry 15 digits of precision, and I get 10.49. If it says what is the height of this thing, well, that was 5x, so I'll just do equals 5 times that x value, and I get 5.83. So that's the values I get right here. Let's see, and make sure they get 5.8277, 5.83 to the nearest hundredth, and then the other answer is 10.4899 rounded to the nearest hundredth. That'd be like 10.49. There you go. And if it says what's the area of this, well, now you know the height of it and the length of it, so you could multiply these two together to get the area of that rectangle if it asks it. And I'll stop right there.